Hello everyone. Today we are discussing about the significant figure. What are significant figure? Significant figure is denote the number of the numerical values present in any measurement. While we are doing any measurements, so how many numbers are present in any numerical value? These are considered as a significant figure. For example, I'll put one numerical value here. It's 5.5. So here, what's the significant figure for this numerical value? Is considered as a 3. Why? Because there are 3 numbers are present, 1, 2 and 3. So for this numerical value, a significant figure, its value comes 3. Here, while we are doing any measurement of any numerical value, like this 515 is denoted the weight of something. Its unit is kilogram. So for this numerical value of measurement, so here we are consider two kinds of digits. First, the certain digits, and second one is uncertain digit. While we counting a significant figure, we are consider all the certain digit and plus one uncertain digit. Means, for example, in this digit, I'll consider as this last one 5 is uncertain, and this 5 and 1 is considered as a certain. So on the basis of that, significant figure value for this numerical digit is 3. So how will denote it? This value is certain and this value is uncertain. I'll explain this by the help of one more example. Like, I'll do a measurement of weight of any object by using one instrument. It's noted by A, and it shows the weight of that object is 51 kg. I'm using one more instrument and using the same weight, same measurement of same object. So it shows the weight of the same object. It's 50. I'm using one more instrument. It shows sometimes 52, and one more shows 53, like 51, and this showing one more show 50, and one more instrument I'm using is 51. So here I says, because the measurement is always vary on the basis of the instrument. If we using different instruments of the measurement of the same object, so there is a very much possibilities to find out the some kind of variations occur in this and any kind of measurement, and this variations is considered as a uncertainty. So here, for example, if we consider one weight which is frequently going to be repeatable, like 51 I consider here. So in this 51, we can say this 1 is vary according to the instrument is going to be changed, and this 5 is fixed. So here this 5 is considered as a certain value, and this one is considered as a uncertain. So there is a possibility on the basis of the uncertainty term is commonly denoted by plus minus 1. Means, on the basis of the nearby result which is more frequently comes and which is considered as the accurate value. So here, if we denoted the uncertainty of this particular weight or measurement of any object, so it's denoted by plus minus 1 of that. Means it will be vary in this under this value on the basis of the different instrument whatever we use to measure any object. So here, if we consider the uncertainty for this result, its value might be vary in between 50 or 52 on the basis of 51 plus 1 52, 51 minus 1 50. So here the uncertainty is plus minus 1 and uncertainty value is 1, and this 5 is considered as a certain value. And what's the significant figure for this? We consider for the while we counting the significant figure, we count all the certain value and plus one uncertain value. So the significant figure value for this digit it comes 2. This is the main logic how we use the significant figure while we are counting a numerical value of any measurement. Like the significant figure value is not depends on the what the value says, means how many decimals are there and what's the ratio of that. So here we are seeing one more example while we are counting the significant figure. So in these 3 digits we can see these 3 denoted the same value, it's 150, but the significant figure value for this is different. So here the significant figure value for this numerical is 3, and for this it's 4, and for this last one its significant figure value it's 5. Means all digits on the basis of scientific reason they are same, but their significant figure value it's different because it depends on the numerical value present in any measurement. So while we are counting the significant figure, we have to follow some rules which will be very helpful while we are counting any value or any measurement, any numerical value of any measurement. So we have to follow some rules for that. So we are consider these rules are: the first rule of significant figure is shows all non-zero digits are significant. So here, like for example, I'll put one value is 2.17, 21.7 or 217. On the basis of scientific numerical value, we can say all are different because on the basis of the decimal present in the digits, but the significant figure value for all this is same. 3, for this also 3, and for this also 3. And if we are discussing what the rule number first, simple thing, we can say all these all are non-zero digit, so we have to calculate as a significant figure. Now we are go to the rule number second. It says a 0, however the digit on its right side, it's not significant. Means for example, if I have any value, I'll put here 0.217, 0.0217, 0.00217 or 0.000. So here on the basis of the above two rules, what's the significant figure for this value? All non-zero digits are significant and the 0 which is present on right side are not significant. So the significant figure value for this is 3. And what about this? There also significant figure value is 3, and for this also the significant figure value is 3. And here we are seeing there are no non-zero digits are present and all are zeros, so we are not considered as a significant figure. So the significant figure value for this digit is 0. Now we go to the rule number 3 of the significant figure. It says the 0 lying between the two digits are significant. For example, I'll put 5004, 5034 and 20001. So according to the rule number 3, the 0 present lying between the two digits, two non-zero digits, which are considered as a significant figure. So the significant figure value for this digit is 4. And what about this? This is also considered as a 4. And for this, the significant figure value for this figure is 5. So these are main 3 rules. Now we go to the rule number 4, how we count the significant figure. The rule number 4 of significant figure says the 0 having on its left, it may or may not be significant. Means for example, I'll put one value here, it's 2500, and one more value I'm putting here, 25,000. So here what's the significant figure for this? It's 4, and for this it's 5. But here if I'm telling for this digit, I'm telling this uncertainty for this digit it's plus minus 10, means this 2 digit is considered as a uncertain. One in 2. So here what kind of significant figure value is comes for this digit? Here I am putting here 25,000 and uncertainty is plus minus 10. So means this 2 digit is considered as a uncertain. So now on the basis of the rule of significant figure, we have to calculate all certain values and plus 1 uncertain value. So here we have to calculate the complete only 3 values of certain value and only 1 value of uncertain. We are not calculating the last one value. So here what the significant figure values comes, it's 4. Same as I am putting here the significant uncertainty for this same value. I am telling it's plus minus 100. So what the significant figure value is comes for this, means there are 3 digits are uncertain and only 2 digits are certain. So here what's the significant figure for this same digit? It's 3. So on the basis of the fourth rule, we can say the 0 having on its left side, it may or may not be significant, because it depends on the number of uncertain value. We are calculating only the one uncertain value while we are calculating the significant figure. For the other uncertain value, we are not calculating a significant figure. This is the rule number 4. Now we'll go to the rule number 5 of significant figure. It says, in the exponential number, the numerical position represents the number of significant figure. Like for example, I'll put one value here, 2.0 into 10 to the power 3. 2.00 into 10 to the power 3. 2.000 10 to the power 3. So here in exponential number, the numerical position represents a significant figure, means only we calculate this numerical position. We are not calculating this power 1. These are not considered as a significant figure. So here what's the significant figure for this value? It's 2. And what about this? It's 3. And what about this? Its value comes 4. So that's the 5 rules by which we can easily find out the significant figure of any numerical value of any measurement. Might be this presentation is helpful for you while we are counting the significant figure of any number of any measurement. So thanks for your patience.